Okay, so today, if we look at our pterodactyl as of right now, you could see our collision detection is kind of janked for our pterodactyl. Yeah. So we're gonna try to fix that today, and the way in which we're gonna go about that is to spawn a pterodactyl not at this logic where it just goes side to side and bounces, but I'm going to put it at my mouse location so I can test for collisions. And then once we get the collisions accurate, this logic should be working. So for right now, I'm going to take off this monster logic here, because that's all the bouncing stuff. Because instead we're gonna be putting it, let me make sure in my update logic we don't have any hidden things. Okay, it should be okay. So it should still cycle through the animation, but it shouldn't be scrolling anymore. Curious if it even appears. Well, it shouldn't be doing that. we're giving it a dy. Where do we give it a dy? Right here. No? See, we don't want to give it dx. Hold on. I want to say that we're just 0 on the dy and the dx. But where are we giving... Here, y gets... Does that stop us from scrolling? Oh crap, this isn't our vulture. My bad. My bad. We need to be pterodactyl and dy. That's why. If we just say, hey, we're actually not having any velocity. There we go. So we're going to be putting, let's see, in our play state here, we're going to give ourselves two variables, a self mouse x. I'm initializing to 0 at the moment. Just want to double check that I'm recording. So for whatever reason, I just forget that I hit recorded. We're good. Okay. So we've got a variable called mouse x, mouse y, and in our play state, we need to say that our mouse x gets, what is it? We've done it a couple times before on the stream, but it's like love.get keyboard, love.keyboard.get. No, love, I think it's love.mouse.get x. Fuck. I have to look it up real quick. Lua love mouse get position. I literally when I googled it, I did the right get position. Silly me. Get position. Oh, but it's like, oh here, love.mouse get love.mouse.getx. 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 I got it. Except that's y and this one's x. So love.mouse.getx. So what we're doing here is we're using a function that love comes with that gets the position of your y and x, and we're assigning it into our variables of our mouse x and our mouse y. And then what we need to do is instead of rendering our pterodactyl at self.x and self.y, we're actually going to be rendering at mouse.x, mouse.y. So I'm going to say, see, but this is wrong. Because I can't use the field from our play state into our class here. So I've actually got to do it. I've got to do that not in our play state, but in our pterodactyl class. I got to do that. So we're going to go back here. We're going to go back to our instantiations. We're going to cut those. Not instantiations, assignments, I guess, or initializations is the word I was looking for there. Pterodactyl. So here in our pterodactyl class, we need a mouse X, mouse Y. And then the same thing, we need to, in our update function, update those fields with the current X position and current Y position of our mouse. So we'll go into our delta time, update function, assign those. And now that those get updated, we can then render not at the pterodactyl's location. See, look, okay, so this is actually different too. We want to keep this because we want to test the collision. So we want the X and Y to actually be moving here. So we need to say, we need to move here, we need to say, instead of updating our self Y and self X by our velocity, we need to update it by this mouse. So we say, we move that value of our mouse X into our self.x, and we move our mouse Y into our self.y. That way, we can still render it at its position, but its position is now tethered to the mouse X via this getX function and Y, respectively. And we still update in our play state, so we should well, 79 if self.x, we don't need this. I don't know why that would crash though. Bad argument 3, number expected got function. 105 got function, bad argument 3. 105, bad argument 3, 1, 2, 3 got a function. Self X is a function. I would think that, we need to use the function to get the integer and store that. Cool. So now we've got a pterodactyl that we're controlling with our mouse. That's really cool. So now we're going to take this, I believe that this is platform 1L, this is platform 1, and this is platform 2. So let's print out the collision info for the pterodactyl and the platform 2. So in our play state here, we'll take this platform 2 and we're gonna be printing out, we instantiate our pterodactyl here in the play state. So we need to run, no we don't, we just in our render function, we need to print out here. We can say, and this is all gonna be in relation to the pterodactyl instantiation of our monster, because we have a self.monster that is actually getting the instantiation of our pterodactyl class. And we're running that against platform 2. So it'll only work for those two, but we'll just know that, and that's the only thing we're going to be testing for while we troubleshoot the collision detection. So we need to say that we're printing out on the screen left collide first, and we're printing out self.monster :left collide with a platform 2 collidable. And we're converting that to a string so we can concatenate with the dot dot to our left collide string and then print that out here. So we can follow suit with the other stuff. So we need right collide, we need top collide, we need bottom collide, and all the appropriate functions. And then, instead of rendering them at the same spot, we just offset by 10 pixels on the Y so that we've got all 4 there rendering. Let's see. Left collide nil value. So our self.monster, we're running left collide. We have left collides with an S. I thought we did not have it as an S, but it clearly is. So in our render, we just need to add the S here. What? Okay. So now we should have 4 Boolean values printed up. Nice. And it's in relation to this platform 2. There we go. So yeah. So this is what's so buggy is like when this flies in, right? Like let's say it's coming in like this, the frame it collides. See how we're triggering 2 different collisions here? So it's like, oh, do we bottom collide or do we left collide? And then it'll be like, well, left collide, and then I don't know, it would just mess it up. So we're trying to get to the point where only one of these is triggering at once. So this is going to allow us to better detect these sort of things. So like, I can tell that our bottom, oh my god, yeah, our bottom collide and our top collide is jacked because this should not be the case. I want to do something here to help me see these. See, look at this. Like if the pterodactyl comes in like this, it's triggering 3 different collisions, which it should only be a left one clearly because the top and the bottom that's just not right at all. So that's why it's messing up so much. I want to go to our pterodactyl sprite. Where's our pterodactyl sprite? Or our atlas rather. So look, I'm going to duplicate this and I'm going to call this original one back as in backup, and then put in my copy as the original title, and I'm going to open that sprite atlas in a sprite here. And what I'm going to do is give ourselves a big, bold outline. Exactly where our bounding boxes are. Because that will help us. It'll help me see exactly how to this is not right. It should go like that. Yeah. Okay, I think that's right. We don't render this 4th one just yet because we don't have player pterodactyl collision, but that's okay. So if I save this and I preview it here, Pterodactyl Atlas has now got the boxes. Cool. Now, when we run this, nice. Now we can get a good idea of, yeah, see, look, why would the top collide be true here? And the bottom collide be true? That should not be the case at all. So, we need to rehaul. And see, look, the left collide has got like 1 pixel, 2 pixel, 2 pixels of detection. And we should kind of have the same thing for the top. Like, the top should only be true for 2 pixels or so. Because that would solve this problem. Because we're not, yeah. So it's like we're doing the true AABB on the bottom and top when that should not be the case at all. So let us go to, sorry, I want to put on a lighter shirt. I'm like melting in here. Maybe I'll just turn this on higher. Okay. So far, so good. We just got to look through all this code and determine what's wrong about it. For right now, I feel like our left and right collides are fine. It's just the top and bottom that's screwed up. And I'm looking at it now, and we do have, I mean, I can see that they're messed up. So I'm going to draw these again and try to figure out what is going on. My pen is freaking dead. I gotta get new pens. So we want the sliver of the top of the pterodactyl to be the bounding box for the top collides. With maybe the bottom half of our collidable. So, gosh, it's hot. I need to just put on a lighter shirt. I'll be right back. So we need, if you guys want to see the little sketch I drew on the bottom here, you know, the top of the pterodactyl with the bottom half of the platform, the black spot is the bounding boxes for this top collides. So we're seeing if the top of our pterodactyl is smaller than, no, this is X. So we're seeing if the leftmost side, oh, and you know what? Oh yeah, this is top collide. Okay, never mind. Seeing if the left side of our pterodactyl is smaller than the rightmost side of our collidable. That's correct. And the right side of our pterodactyl is greater than the leftmost side. Side is greater than the leftmost side of our collidable. Those two are correct. Now we're seeing if the top of our pterodactyl is smaller than the bottom of our collidable height. Yeah, and then we're seeing if, see, this is where we're messing up. We just want to see if 3 pixels from the top of our pterodactyl is greater than the halfway point of our collidable. Is that right? So we're seeing if the top of our ostrich is smaller than the bottom part of our collidable, and we're seeing if 3 pixels in from the top of our ostrich is greater than, meaning below, the halfway part of our collidable. Yes. So let's see if our top collides is looking better now. So top collide, that's true. Yeah. See, so like that's too much. We want it to be like 3 pixels or something like this. So it should be false here, here, and here, and here. Not there. So how do we shift that? Because we need it to be only like 3 pixels worth. Maybe even 2 pixels worth. So our 2 pixels from the top of our pterodactyl would have to be greater than, I'm gonna say we can do y plus its height minus the 2. So that should give us 2 pixels lenience. So 1 true, 2 true. No, 3 should be false. Nope. What the heck? Oh, top collide. I'm looking at the wrong one. True, true, true. Yeah, we need it to be a little less sensitive, so smooth it. Let me just see that. So top collide, true, false. Okay, so not quite. That's only 1 pixel of lenience, but this might give us the 2 pixels. There's true. There's true. Now 1 more pixel should be false. Yeah. Okay. So our top collide is looking better. So now look, we can't trigger a top collide like this, where we used to be doing that. It would only be a top collide if it's way down here. So that gives us more accuracy, which we need for the bottom collide, and then we can turn our stuff back on and see if that fixes our weirdness. I don't like that it's like +2 and -1 here, kind of random seeming values. So maybe we say, if this one is too higher, maybe we say this is just self-y, this is -3. Is that the same thing? True, true, false. Okay, that's a little cleaner. Now, see, in the 3 pixels is the same offset we have on the side collisions, so I think that's good. It's either 3 or 2 pixels is going to be the most beneficial to us, because we want it to be more accurate. So only it just depends how fast our dx or dy is going, if we can ever be past that, because that would create problems. But I think either 3 pixels or 2 pixels is the sweet spot for that. So let's figure out our bottom collides fix. And look, I can see that we're not modifying it by anything, so it's the true AABB right now. But we need to do the similar thing. Oh, come on. And really helps me to see the little sketch. So it really helps me. Okay. So checking to see if the left side of our pterodactyl is smaller than the right side of our collidable. The right side of our pterodactyl is greater than the left side of our collidable. Those are both right. Then we're seeing if the top of our pterodactyl, the top, see, look, that's why we're fucking up there. We want this to be the bottom pterodactyl minus the 3 pixels. So the top side of our bounding box, of our bottom bounding box of our pterodactyl, we're trying to see if the top side of that is smaller than the top side of our bounding box is smaller than the collidable's halfway point. And we could also do this by 3 pixels or whatever, but I don't think it's that necessary. And then we're seeing if the bottom of our... Wait, so we're seeing if the top side of our collidable is smaller than the bottom box of our... Goddamn, smaller than the halfway, the bottom of our collidable bounding box, and then we're seeing if the bottoms... Wait, god dang, okay. God damn, sorry, it's so confusing. Yeah, so we're seeing if the bottom side is smaller than the bottom of the collidable, and then we're seeing if the top side is greater than the top side. So this would actually be top side. Yeah, we actually just want this. We want the bottom, yeah, the bottom of our pterodactyl needs to be smaller than the bottom, meaning above the top of our bounding box. Or no, the bottom of our top side bounding box or collidable, and the top side of our pterodactyl bounding box would need to be greater than the top collidable. Something like that. Now we don't use a collidable height divided by 2 on any other functions, so I'm thinking just do this where we say the bottom of our ostrich would have to be smaller than, would actually be this plus 3, and the top would have to be greater than the fuck, hold on. Top would have to be smaller. What am I doing, man? It's hard for my brain to wrap around this. We're trying to see, so the first thing we're testing is the bottom of our ostrich. So or the pterodactyl. So we're trying to see if the bottom is above the bottom of our bounding box, so smaller than I plus the 3 pixel buffer, and then we're trying to see if the top is greater than the very top. Okay, I think that's right. So now we should have more accurate bottom collision. So look, it should be true right here, which it is not. It is just completely wrong. So what are we doing wrong? Our left side needs to be smaller than the right side, and our right side needs to be greater than the left side. Then the bottom of our ostrich needs to be smaller than the collidable's y plus 3. So the bottom needs to be smaller than that, and the top needs to be greater. What's going wrong here, man? We don't have... See, we have two numbers on the bottom, but only here. So on our top collide, we're saying if the top of our ostrich is smaller, top of our pterodactyl is smaller than the bottommost part, and see, this actually should be right. Why are we're only testing the top side twice? This should be wrong. Top side. Fuck. Shit. Yeah, this is wrong. Top side of our pterodactyl would need to be smaller than the bottom of the collidable, and then the bottom of our pterodactyl would need to be... See, but it's not the bottom of our pterodactyl, it's actually the bottom of our bounding box would need to be bigger than the top side of the bounding box, which is like that. Let me see if the top collides is looking right. So, yeah. True, 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 and then false. No. It should be false a lot sooner than that. Yeah, we took this out. So our top would have to be smaller than the bottom of the collidable, but bigger than the collidable minus 3. Okay, now that kind of makes sense. And then here we're checking bottom collide, so why don't we just do self y plus height for both of these? And we're seeing, hey, our height, or the bottom of our ostrich should be smaller than the collidable y plus its height. No, just the collidable y. Our bottom would need to be smaller, no. Yeah. Our bottom would need to be smaller than plus 3, giving us that 3 pixel buffer, and then our bottom would also need to be bigger than the very top. So let's try that. We've got true, true, false. Cool. So we give us, and then top collide should be same, true, true, false. Okay. Now left collide, we should have 3 pixel buffer here on left collide. So we have true. Let's see how only 1 collision is detected in this scenario. At the beginning of the episode, we had 3. We had top, bottom, and left. So that should fix a lot of our problems. Okay, yeah, we got 2. Yeah. Okay, so our right collide is janked. Because we need 1, 2, and then... Yeah, our right collide is messed up. So we're checking. Oh my god, yeah, this is a mess. I want to like just start this one from scratch, man. This is disgusting. We're trying to see if the left side of our ostrich pterodactyl, sorry, I keep on saying that. Left side of our pterodactyl. Well, no, we need the right side. We only worry about the right side on this one. So self x plus its width. So our rightmost side of our pterodactyl would have to be smaller than the x plus the 3 pixel buffer, and the right side would need to be bigger than the leftmost side. That's right. And then our the top of our pterodactyl would have to be smaller than the top, and pterodactyl would have to be smaller than the bottom of our collidable, and it would have to be bigger than the top of our collidable. Yeah. Let's see. We should have a 3 pixel or 2 pixel buffer here. No, my collide is not getting true. What are we doing? The rightmost side would have to be smaller than collidable's x plus that 3 pixel buffer. The rightmost side would also have to be. Oh, we need to. Yeah, this is where we messed up. We have to see. Shit. So. Okay. Top of our pterodactyl would have to be smaller than the bottom, and the bottom of our pterodactyl would have to be greater than the top of our collidable. So we've got true, true, and then we should have false. Correct. Okay. So now, ideally, we only have one collision at any given time, which is looking to be the case, which should fix all of our issues. So now it's much more sensitive, only detecting collision. Now it gets tricky when we're like this. Actually, it still works. Yeah, it only, if we're exactly pixel perfect diagonal, that's when we get 2. But if we're anything more than that pixel perfect diagonal, we shouldn't be able to get 2. So I'm gonna turn back our stuff. If we go to our play state and we turn back on our logic for all of this, then we also need to turn back on our original instantiation for our delta x and delta y. We're still we're rendering at our mouse still, which is wrong, so we need to turn off our mouse update, turn off moving our mouse into our position, and go back to updating our position via delta X, delta Y. Yo. Okay, I forgot to turn off, there was another thing. We turn back on, rather, this. Yes. Fuck yeah. Yes. So much better. Now it's gonna get kind of stuck up there because it's... Yeah, it's gonna get stuck up there, but it looked right. It all looked right. And it would do, you know, it's gonna do the same exact pattern unless we switch the instantiation X, which we can do that by we can shift it over an extra 30 just so we get a different pattern. That's the corner I wanted to test, and it looked like it worked perfect. That's awesome. And then it's going to get stuck up there, but that's fine. Oh, it didn't. It actually made its way down. That's awesome. It looks so smooth now. That's so sick. That's so cool. Fuck yeah. Okay, so in the coming episodes, we need to add pterodactyl to vulture collision so they can bounce off one another. We need to add ostrich to pterodactyl collision 2 ways, mostly it killing us. However, whenever its tongue is out and its mouth is open, if it's on that frame and our joust is in the acceptable tolerance of being in his mouth, that's when we can trigger the pterodactyl to be killed. So that's the other end of the player to pterodactyl collision, and then we need to worry about the timer for its spawning, which we figured out is about 20 seconds per vulture, as long as that timer gets reset as long as you kill a vulture, or every time you kill a vulture. And then we also need to deinstantiate our pterodactyl upon our player's death. And then we also need to give our pterodactyl a random spawn point, either from the right going left or from the left going right. And then probably a little bit of variance in the Y positions as well. That's awesome. That looks crystal clean collision detection on that. I haven't seen it mess up once. Super happy with that, and that it hit that corner case. Ooh, that looked like it would have been the pixel perfect corner, but it's still working flawlessly. I think I'm happy with that. So what we can do here now is go back to our atlas, delete our red border atlas. Oopsie, wrong one. Pterodactyl atlas, delete our pterodactyl atlas, and rename our pterodactyl back to the correct name, and we should have fixed collision. Now, there is the issue. Well, so when his wings are down, the top of his bounding box. See that? When his wings are down, the top of his bounding box hits before the top of his head would hit. So it's almost like if his wings are down, it would change his hitbox for the collision detection. I don't know if I want to actually change that though. That seems pretty nitpicky. and it could make issues on a frame by frame basis of that detection going on. Yeah, I don't think I'm gonna change that really. This is so sick. This is so cool. That's so fucking cool. Yeah, that's awesome. I'm so glad we fixed that. Took us a couple episodes. I was like me, I was thinking we would get this far on the 100th episode. I wanted to get this far on the 100th episode. But it's okay, it just takes a little longer. Everything takes a little longer than you expect it to, but I'm super happy with this. So we can go ahead and turn off. We can not only turn off our debugging, but we can go ahead and delete. Actually, I'm not going to delete the mouse stuff just yet because I want to test the collision for our player killing our ostrich as well. So I want to leave that logic in here in this commit, I guess. Because either we got to move the ostrich or move the pterodactyl. Might as well move the pterodactyl. Oh. Yeah. Let's look at our git diff here. We added the mouse positions. We can turn that off for now, at least the node amount. Then we fixed our collision detection, which we had to change every single. Actually, our left collision was working properly, but our right was messed up. Our top was messed up and our bottom was messed up. That's all we've got. We've just got debugging info. We changed our pterodactyl instantiation by 30 pixels, which doesn't matter just yet. I mean, it doesn't really matter. Add everything to the staging area with a message saying fixed pterodactyl plus platform collision. Fixed pterodactyl and platform collision logic. And then we're going to get pushed to our origin main. Call it a successful day. So yeah, we're going to be doing we've got to set timer for pterodactyl spawn, randomize pterodactyl spawn points plus direction. Then we need to add pterodactyl plus vulture collision. And then we need to add pterodactyl kills player logic, then player kills pterodactyl logic. And then we need to deinstantiate pterodactyl player death, and then set timer for pterodactyl spawns. Yeah, 20 sec per vulture. And then there anything else? Just scared me. I don't know. I mean, it's quite a bit of stuff left of the pterodactyl still. That's super cool. It's really starting to feel like a fleshed out game, you know? I mean, as soon as we get the tier system for our vultures and one more wave, it'll really start to feel like a whole new game, like a real game, you know? It's gonna be awesome, man. Okay. Well, I'm gonna call it a day because I've got to still prep for. I gotta prep for a shoot I got tomorrow morning. But we committed and we pushed. So yeah, I'll call it a day and I'll see you guys tomorrow.